Hello, this is a high-level overview of CFD web applications by TotalSim, and I'll be your host, Paul Grunbacher, presenting. And this is just to give you essentially a top-down view of what the TotalSim Web platform is, why we're providing it, what the guiding philosophy of it is, and where it came from. So the web platform is intended for creating high performance computing simulations, and we want these simulations to be able to be generated from your web browser. And so you just need a web browser to connect to the server, use our interface, and you'll be able to quickly start generating simulations. And that's part of the goal of this platform, is that you won't need any prior experience when performing these simulations. And this platform was originally part of a partnership with the Ohio State Supercomputer Center, and it was part of a statewide drive to bring supercomputing and simulation to the local level for small manufacturing firms and small engineering teams to essentially expand out of academia and large companies using simulation software, but enable it for many people to be able to perform their own simulations on the supercomputer. And so for a lot of this talk, we're going to be using CFD simulations as an example. So TotalSim is primarily an aerodynamic engineering firm in that we help teams design their vehicles for improved aerodynamics. And that means, decreasing drag, improving the downforce of racing vehicles. And so to help with this design process, we use CFD simulations, and we essentially perform virtual wind tunnels for vehicles to approximate what the drag and the airflow around a vehicle is. And so you can see the motorbike example below. And so we use these CFD simulations to basically do rapid iterations of simulation. And these simulations use the CPU to perform these physics approximations. It's an iterative process to converge to the final solution. So that means that they can take quite a bit long time of iterating through the physics to get to that final solution. And that increases the computation time as well. And finally, these results are gathered into final drag values or lift values or downforce values for final decisions to be made about new parts or new designs of the vehicle. So when you're wanting to run a CFD simulation, you're going to have quite a bit of hardware required. You're going to need at least 48 processing cores, 6+ gigabytes of storage space, and to do that, there's no usually one single desktop or machine that can do that, so you'll need a cluster of machines to set up and maintain within your office. And so a large company, if they're running multiple simulations and they have multiple teams wanting to do these simulations, they'll have their own, basement cluster that they will maintain, and several server racks and whatnot. But if you are a single user or a single designer of your vehicle, you're not going to have those resources available. So the only real option you're going to have is to be able to use cloud resources. And so that's what we are doing with the web platform, is through your browser you'll be able to connect to the Ohio State supercomputer resources and take advantage of them. And at that sort of scale, you can take advantage of the pricing, the scale of pricing, as well as the scale of performance when maintaining large clusters like at Ohio State Supercomputer Center. Also, when you're wanting to do a CFD simulation, you're going to have quite a bit of engineering background and have probably taken several courses on how to perform CFD simulations, because it does require a base knowledge of how to mesh the geometry, what sort of boundary conditions you need to set up, what sort of solver settings you need to get the turbulence conditions you want. And so you only have a few options. You can use open source software or software developed by academia, but you'll find that that won't have as much documentation or no documentation as you would hope for. And even with the documentation, you'll be hard pressed to find examples that fit your exact need. You can license the software, which comes with its own cost. You can imagine, $40,000 at once for a license, and you'll still need to be an expert user on the software itself to be able to use it, because the software has to be generic enough that it can fit many different users' needs. And if you are having to find an engineer that can do this, you're going to have to hire one, and oftentimes that engineer that you've hired or found help to help you, a lot of that time that engineer is also going to be involved with the major aerodynamic decisions or the basic physics decisions when designing the final design. And so the less time you can have that engineer debugging or working through the software that they're using, and more time on making decisions and designing and doing physical testing and planning, you're going to be better off the less amount of time you need to learn the software you're using. And so what TotalSim does is we focus on trying to get the interface so that it's as simple as just setting essentially what the physical settings would be if you were doing this as a physical test. And so in the image I'm presenting below, you can imagine if you're just doing a regular drone simulation, you'll be wanting to have some basic parameters like the pitch, the roll, the yaw, the atmospheric conditions, and what the free stream velocity of the air is against the drone. But you don't want to have to worry about the settings for what the mesh resolution should be or what the boundary conditions or whatnot are. And so that's our goal, is we focus on tailored solutions so that we can present an optimized form with easy fields to understand. And that means basically we tailor a solution for every single possible simulation that the user could imagine. But that also can take time on the TotalSim part, and so we strive to kind of make these forms and fields quick to generate for users. But we do a lot of the thinking for the end users, and so that's kind of how we try to make it as simple as process as possible. And so ultimately, you don't have to worry about the CFD specific parameters. You only have to worry about the fields you actually care about when running a simulation. Likewise, once you've run several simulations, and this is the point of using CFD and high-performance computing simulations, is that you can generate lots of results really quickly. You can run the simulations in parallel so that you can get them all back at once. And so compared to physical testing, where you've got days and days of work, you can instead use massive computing resources to perform a full sweep of simulations at different settings. And so that's the first time save, is just switching from pure physical testing to a mixture of initial CFD computing testing followed by that physical testing. And so even when you've done this switch and you've been doing computing simulations, you're still going to have a lot of results that you're going to have to spend a lot of time in, and then you'll suddenly realize with all that learning and training you have to do, you suddenly lose all that time you gained by adding in computing simulations. And so what the TotalSim Web platform strives to do is to basically automate that for you. So instead of having to calculate custom fields or using certain softwares to go through your results and generate images and take screenshots, what the TotalSim Web platform offers for you is we automatically generate images, we automatically extract movies from the raw CFD data and present that to you in a easily accessible web interface where you just simply click through variables you want or click through the views you want, or you can go through movies and step through them. We automatically generate that for you. And we still offer the option to be able to create your own custom images and movies if we don't fit what you need. And likewise, instead of having to go through the raw data and putting it all into a final Excel, we automatically will tabulate that data for you. And so you'll be able to use the tables generated through the web applications to be able to compare results and be able to download Excels and be able to perform plots and perform final reports. And so these custom PowerPoints and reports and Excels being generated through the application are downloadable, and it's part of the philosophy of the application that we try to automate as much of the process of a CFD or aerodynamic engineer would be doing. And so a big part of that process is generating PowerPoints to be presented and taking all the simulations you've run. So if you've run 10 runs or 20 simulations, you'll be able to just generate a PowerPoint with 20 or 10 slides with all the views and variables you wanted to be able to compare across those runs. And that is a big part of the process, is being able to quickly compare and be able to tell the differences between different simulations at different parameters. And so that leads us to the guiding philosophy of the TotalSim Web platform, which is that essentially we provide a tailored solution for each unique need and industry that we can predict. And so you can imagine the automotive versus an aerospace simulation is going to be completely different. And so if we want the user to be able to guide through the geometry setup and setting up simulation and being able to provide assistance for analyzing the results, then what TotalSim does is for every time we come up with a complete solution and process for each of those different simulations, we'll basically publish a new recipe. And so when we're happy with our airfoil simulations internally, we will publish it as an airfoil recipe. When we have spent some time over the vertical takeoff simulation, we then publish that as a recipe into the TS Aero app, and all the users of the TS Aero app are then able to take advantage of the vertical takeoff recipe. And so essentially, a TotalSim engineer creates a tailored solution, publishes it to the users, and then the users are able to basically perform the same amount of simulation and analysis that a TotalSim engineer could do internally. And so likewise, whenever there's future industries or future apps, we essentially create a new app with whichever recipes we can create for that user. And so ultimately the final goal is to give users that streamlined process that is as easy to use as possible, with as little knowledge necessary besides the actual testing that you want to perform, and to automate the entire CFD process so that there's little to no intervention needed for running a simulation from start to finish and getting the results back. And so that ultimately is the philosophy of the TotalSim Web platform and the final high-level overview. So thank you for watching. We'll have more videos available for diving into the application and using it to come. Thank you.